Anybody know what that computer is? Anybody remember that? That's awesome. And that's not even 50 years old, obviously. It was just the oldest one we could find that fit on a slide. So, since you were little computer science majors 100 years ago, this is exactly how the world has operated and does operate. Monolithic stacks of computing elements. Yeah, it works the same. Doesn't matter if it's a pyramid or, in this particular case, that particular stack. You got an app, talks through an OS to a big stack of stuff. Anything fundamentally different today? Same thing. Same thing. The root may change, the presentation layer may change, all the same things. Things get bigger, faster, better. Right, here's to, wow, what did we do? We disaggregated storage, physically disaggregated it, create logical presentation views all throughout that stack, but it's the same thing. Everything we do today, by and large, 99% of what we do today is built on monolithic infrastructure stacks. Now, why did we do that? Anybody want to guess? I'll give you the answer. Because it worked. That's why we did that. So what we've had to do for 50 years, again, any different piece can be, this one's better than that one, mine's bigger than yours, this one's faster than this, et cetera, et cetera. But fundamentally, architecturally, everything in our world has primarily been monolithic stacks of computing. The reason that we did it is because it works. Why did it work? Is because when we could contain an application to a physical set of infrastructure, we could plug whatever holes we had to, optimize whatever it was we needed to make sure that it fit within our parameters of acceptable service levels. When we added more users, when we needed more transactions, when we got whatever else jammed down our throat, the industry responded by fixing those problems. Moore's law is why this has worked. So we've added new use cases because we don't anticipate all of them. We didn't think everyone in the company was going to be on the computer systems back in the day. They were very specific, just accounting or just whatever, engineering, very specific use cases. But by and large, the way we compute an application is based on build a stack, don't let anybody else touch it. Interdependencies are the death of our computing environments. Hard to fix a siloed stack of stuff with one application running. It's hard, right? Because things are so fast and so incredibly powerful. It's difficult. The tools have never kept up with the overall capabilities of the systems to be able to help us isolate and figure out what causes the problem. We can find a fire normally, and in the older days, when it was purely a single stack of stuff, you just look for the red light. What broke? And you fixed what broke type of stuff. Red lights are hard to find today. They're virtual. Where's that? I don't know. Here's where it's a ghost. It's an image that you can kind of see there, but fixing things becomes harder and harder and harder as we move along. So the point of this slide is that 50 years ago, we had it, everything was in one box. Today, it's not in one box. But logically, it's still one box. It's still one monolithic instance of an application executing through its own, by and large, specific kind of stack of hardware. We've disaggregated storage. We made it look different. It sits out there. As a matter of fact, storage was the first truly virtualized outside of the mainframe. In the distributed and open world, storage was the first truly virtualized stuff. And by truly, I meant we made something that was physical look different than it was. Fascinating.